Hello everyone. The purpose of this video is to introduce you to the concepts of SIC programming. SIC stands for Simplified Instructional Computers. So the first program that we'll see is to write a SIC program to swap the values of alpha and beta. So say alpha is equal to 5 and beta is equal to 3. And we have to swap these. So we'll make use of gamma and we'll say gamma is equal to alpha. So now we have the value 5 inside gamma. Then we'll override the value of alpha with that of beta. So now alpha has become 3 and we can just copy the value inside gamma to beta. So now beta has become 5. So we have swapped these numbers. The same logic is applied to SIC programming. So we need to have a program name, say swap, the start assembler directive and the starting address of the program. So we have given 1000 here. And we can give a name to the first executable statement inside the program. So we have used first. Now this is LDA, that is load accumulator. We are copying the value of alpha into the accumulator and we are storing that in gamma. And we are loading the value of beta into the accumulator and we are storing that in alpha. So now alpha has become 3 and the value inside gamma is taken to the accumulator and we are storing that in beta. So now beta has become 5. So we have swapped these numbers. Now alpha, beta and gamma, they are memory locations. So we have to use the assembler directive reserve word because we need to store integers and we have to store one value each. So that is why 1 here. And at the end of the program, we need to indicate it with the end assembler directive and we can optionally give the label for the first executable statement. That is, here we have used first. So here also we will be using first. So that is the program. So now we'll see how to write the same program but by using SIC SIC. So now what we have done is we have copied the value of alpha into the accumulator and we are copying the value of beta into the S register. And we are storing the value of accumulator into beta and we are storing the value of S register into alpha. And again we have to define what alpha and beta is. Next, we need to write SIC program to set alpha equal to the integer portion of beta divided by gamma. That is, we need to store the quotient inside alpha. For that, we have given the name of the program as division. Now what we are doing is we are copying the value of beta into the accumulator and we are dividing it by gamma. The result would be there in the accumulator and we are just storing that value inside alpha. So we have the quotient of that in alpha. So next we'll write the SIC program for this. So first what we have done is we have copied the value of beta into the accumulator and the value of gamma into the S register. Then we have used div R. Div R, the format is R1, R2, the registers. Now it works in this manner. R2 is equal to the content of R2 divided by the content of R1 and the result would go into the second register. So here it will divide and the result would be there in the accumulator. So we are just storing that value inside alpha. Now we need to store the remainder also to delta. For remainder finding, we'll use this logic. Remainder is equal to dividend minus divisor into quotient. So here the dividend is beta and divisor is gamma. So we have to store the remainder in delta. For this, what we have done is we have copied the value of beta into the accumulator and we are dividing it by gamma and the result would be there in the accumulator. So we are storing that in alpha. Then we are multiplying it with gamma. That is, the value inside the accumulator is multiplied with gamma. So this part is done and we are storing that in temp. So this is temp now. And we are loading the value of the dividend, that is beta, into the accumulator and we are subtracting temp from that and the result would be there in the accumulator and we are just storing that in delta and we have to define what alpha, beta, gamma and delta is. Next, we'll write the same program but for SIC XC. So here what we have done is we have to load the accumulator with the value of beta. Then we are loading the S register with that of gamma. Then we have used the div R and the result would be there in the accumulator and we are storing that in alpha. Then we are using mullar and we have to multiply S comma A. The result would be there in the A register and we are loading the S register with that of beta and we are subtracting that. So you know that we'll be subtracting beta minus the divisor into quotient and the result would be there in the S register and we are storing that in delta. Now we need to write a sequence of instructions for SIC to clear a 20 byte string to all blanks. So for this purpose, we'll be using indexing, that is the X register. So first we are loading the X register with the value 0 and we have to tell what 0 is. So 0 is word 0. Then we are loading the character blank into the accumulator. We are defining blank to be that space and we are storing that in the str, that is the first location of str, that will be the 0th location. So assume this is str, so in the 0th location we have copied that blank. Next what we have to do is we need to use the ticks instruction and we have to compare with 20, that is the size of the string. So we have defined 20 to be the integer 20. And what this ticks will do is it will increment x. X is equal to x plus 1. So it was 0 and now it has become 1 and it will be compared with the value 20. And if it is less than that, the loop would be repeated. That is, next time it will do with location 1 and it will copy blank here also. So that is done till the end of the string. Next, we'll write the same program but for SIC XC. So here we can use immediate addressing. So we have initialized the X register with the value 0, the T register with the value 20, that is the length of the string, and the accumulator with hash 32, that is the ASCII code for space. Now we have done the same thing. We are storing the value of space into the first location of str. Then we have used ticks r and the t register. That means it will do x is equal to x plus 1 and it will compare with the value inside t, that is 20. And if it is less than 20, the loop would be repeated. So the same process is done for the next location. So that is about SIC XA. So hope you have understood these programs related to SIC and SIC XC.